Hi everyone, so this is CSE535. So we are group 8. Our project is called the Field Information Navigation. So it's to find the routes between 2 points on the map and add a series of calculations. So this page is our main page right now. We will improve the UI interface later. So this time I will just show you guys the function workings. After click the button, we can see the locations on the map. So this number is located. For this project, we located the search area of this project is at the template. Right now I can see where I am. When I zoom in on the map, we can see real-time traffic informations here. And there are green, yellow, and red is representing different traffic conditions. At the same time, we can see the shops or restaurants on the map. As we zoom in on the map, we can see the traffic light. It's a real-time traffic light on the map. Also, we can add the stop point on the map. We add the stop point functions in this project. I just using the fingers to touch the skins, and I can add the stop point. As you can see, I can add the stop point as much as I want. Also, I can delete the stop points still using fingers. Just retouch the skins. Okay, I will show you guys next functions. It's called the navigation functions. I want to show you guys where I go. I can choose in this high school. Let me search this high school. And click the search. There has the 4 routes to appear the skins, and so we have the time, distance to the skins, total intersections, total time, and total distance. Also, so we can explore this route to the Google Map, and we can compare the Google Map route difference, and we can find the shortest routes for this way. So I will show you guys how to do this. It's high school, and explore to the Google Map. Okay, so these are routes for the Google Map.
Oh, so will be the second part of our code. There are 2 main views. The first one contains only 1 button. In the second view, there is a map on the second view, and here is the code how we implement Google Map on the second view. Okay, so at the same time, we will assess the current location of user where he or she in, and then user can we allow user to search the destination, and here's the search function. So after the destination was found, we will return such a GPS location, and then we will call the backend algorithm. And in the backend algorithm, it will help user to find top 5 routes that span least fewer, and also will be the shortest path for each route. And here is the code that how we call the backend algorithm and return such a set of paths. Okay, so let's focus on the how we perform the search algorithm. So first we store each intersection as an object, and there are three main attributes, which are latitude, longitude, and traffic line timing. And then we will be stored in our database. So in our road prediction.java, it will perform the breadth search for each possible way each possible way, and then we will return top 5 routes. And based on the route, we will for each route we found, we will return a set of intersection object, and which will be returned in here. And then after that, for each route we found, we will call Google API, and also we will set up a waypoints for each intersection. Make sure that the direction API will go past the intersection, and then we can find we can plot our route on the map. And here's the code. And the scope of our project will be based on these two locations. And the location, and if we view it on the map, and we're basically inside this, and this is the map for our scope. I'm sorry, the scope of our project, which basically inside the Tempe. And thanks for watching.
So this function is where we use to calculate fuel consumption. So we first call direction API, call Google Direction API, and this function takes two strings. One is latitude and one is longitude. And for these two strings, the index 0 should be the start position, and the index the last one should be the destination position. And we call Google Direction API and return a route that start from the first coordinate and go through all the intersection coordinates along the way and end at the last direction, the last coordinate. And the Google Directional API will return a destination and time consumed. And then we call calculate field based on the distance and time return. So the distance is the total distance along this route, and the time is estimated time along this route. And the good thing about Google Directional API is that it automatically accounts for road condition. So the traffic, it automatically accounts for traffic and return the time based on the traffic. So that's good. So we can use the time and distance to calculate the average speed the user use along this route. And we use the average speed to determine what fuel efficiency that the driver have. So we based on this graph. So you can see when the speed is increased, the fuel efficiency increases, and then if the speed increases a lot, the fuel efficiency will then decrease. So we basically approximated this graph into three linear functions. So from here to here and one, and from here to here that's the second one, and from here to here the third one. You can see that we have three conditions, each calculate the appropriate fuel efficiency. And after this unit changing from meters to mile, and from seconds to hours, and then after determining the fuel efficiency, then we calculate the fuel consumed without any idle time. And after some research, we determined that the average idle fuel consumption for a car is approximately 0.3 milliliter per second. what we determine this value is, and then we calculate the total idle fuel consumption, which is using the number of intersection times the average right light time. We can determine the total waiting time in second, and then multiply that with idle gas per second, and we add them together, we got a total fuel cost. And that's how the total fuel cost is determined. And after that, the user can choose which route to follow based on the total fuel consumption.